Hello, my name is Cameron, and today I'll be taking you through my submission for MATH2270 Assignment 2. After searching through some open source datasets online, I came across the NASA data portal as well as the US Geological Survey Land Cover Institute. Both organizations provided geospatial data available for public use. After searching through their data repositories, I decided to explore the number of meteorites found on Earth. The ones I'll be looking at are the meteorites that have already landed on Earth. When a meteorite is found by an individual, the geospatial coordinates are recorded according to the initial finding site. I had two main questions for the data. Where were the meteorites being found, and were there any factors that influence this? The region I'll be focusing on today is Central Africa. I decided to produce two plots that explored the finding sites for meteorites as well as the vegetation density for Central Africa. Looking at the plot on the left, you can see that the count of meteorites found are following a color gradient. This simply means that blue pixels show lower amounts of findings, whereas red pixels show high amounts of findings. The green circles also indicate the locations of modern astronomical observatories in Africa. It's fairly easy to see the areas that have very high counts of meteorite findings. If you look at North Africa, you can see Oman, Libya, Algeria, and Morocco have the highest counts for meteorite findings. It seems like the further south you travel, the less meteorites are being found. I initially thought population counts of each city would correlate with the amount of meteorites found. However, it seemed like another factor was affecting this. This led me to producing the plot on the right. The plot shows the vegetation density of Central Africa according to a color gradient. Light blue areas show areas with very low vegetation, like deserts, and the darker shades show areas such as forest and savanna woodlands with very high vegetation. If we pair the plots together, it looks like that the higher counts correlate with very low vegetation areas. Searching online after this discovery led me to finding several news articles detailing popular meteorite finding sites, which included Morocco and Oman. It seems like terrain types play a major factor in finding meteorites. Although the plots seem to provide some good insight, there are still some factors that might affect the finding sites. External factors like political instability could account for low meteorite findings in Yemen and Egypt. Also, it's possible meteorites that have landed on Earth were a part of a larger mass that broke apart on atmospheric entry. In summary, the plots generated provided insight through the use of symbol color gradients and geospatial data. North Africa looks like a hotspot for finding meteorites, and terrain seems to be a big factor in finding meteorites. That concludes my presentation on the meteorite findings of Central Africa. I hope you enjoyed, and thank you for listening.